Hello, my name is DJ, and we are Team 1757 Nanobots. We are here to tell you about our robot. To start us off, Daniel will tell you about the ball launcher.
Ball launcher is an arm attachment that was built like a catapult. We are using the arm to throw the ball for sport. How it works is pretty simple. We have the arm at a position. When we back up, we get a good shot into the net. We've tested it, and our consistency is 80%. Now, Brandon will tell you about the changing conditions attachment.
This attachment is a squiggly arm on the side of the robot that is turned by a medium motor. This arm will move changing conditions and turn the engagement pinwheel after it's been engaged. Now Jackson will tell you about the engagement attachment.
The engagement attachment is an arm that will activate the engagement motor so the wheel can be spun to add points to the end of the run. It is above the robot, and as the robot moves forward, the wedge catches the yellow bar and engages it. Now Garrett will tell you about the cloud access key.
This key on the back of the robot is made to activate the SD card for cloud access. Cloud access is a mission that the robot has to do. To get the points, you will need to insert the key to activate the SD card. Now, Daphne, will you talk about the engagement one?
In this program, the robot should complete changing conditions, engage engagement, pick up the green loop, complete cloud access, pick up the loop in community tree, and return to base. Numerous attachments are used for this trip. The robot will need the cloud front lever, the spinning side attachment, the engagement attachment, and the community tree attachment. The robot's right wheel should be lined up on the edge of the LEGO logo that is closest to the south wall. The right color sensor is halfway in the logo. The lever in front of the robot that is attached to the medium motor should be in an upright position. Push it up and turn the gear-like thing connected to the motor clockwise until it's tight. The long arm that gets the green loop from community tree should be leaning towards the back of the robot. The spinning attachment on the left side of the robot should be vertical while starting with the half with the tire on the top. Once activated, the robot should complete its assigned tasks and return to base. Now Dominic will tell you about the sports run.
To start out the run, we have the robot go forward and get out of base, then turn right. It will go forward again, ending up beside the sports. It turns again and passes communications. After that, it will turn once again and goes behind the boundary lines, turning around completely. Then it shoots the ball into the goal. After shooting the ball, it turns towards robotics and goes forward until the color sensor sees the green line. Next, it will lower the front arm and pull back, completing remote communications. After that mission, it will return in line file and push the slider in for sensors and get the loop. Then the robot will back up and use the ball launcher to pull the reverse engineering basket back to base. Now Dave will tell you about the door line.
First, the robot moves to the door, then triggers the door handle. It does this while it's pushing apprenticeship. After the robot unlocks the door, it moves forward until it senses the red line. Then it moves forward a little further. It puts the arm up and then backs up. This leaves the apprenticeship in the right spot. The robot then turns towards search engine. It will move forward until it pushes search engine slider. Then it will move backwards. The last step is getting back to base. The robot will turn and zoom forward 5 rotations, the perfect amount to get back into base. Now Andreas will talk about the sensors we are using.
Our sensors have been specifically chosen for our very needs on the field. We chose the ultrasonic sensor to see certain objects on the field. We chose 2 color sensors so that we could see certain colors on the field and be more accurate. We have also chosen a gyro sensor to turn when we do not have color lines to turn to. Now Moses will discuss the tool changes we are doing.
In terms of efficiency, our robot has many accessories. That was to accomplish its many missions. If it had every tool attached at once, it would only be able to do the missions around base because the robot would be too big to make all the twists and turns and too huge to fit in the tight spaces. This way, as long as we move quickly, the team can get more points.
I hope you've enjoyed our presentation. We look forward to demonstrating our robot's moves for you on the table.